Solving polynomial equations in factored form. So this is our introduction to solving polynomial equations. We've done a lot with polynomials so far, adding, multiplying, learning different patterns, things like that. So now it's time to put them into equation form and actually do something with it. So before we go on much farther, let's stop and take note of this little bunny race that they have up here. For whatever reason, they've trained rabbits to jump over hoops. So, I don't know. Usually that's dogs, sometimes horses. Never seen a rabbit. But again, this book kind of has some crazy pictures in it anyway. So, anyway, enough of that fun stuff. Let's go down here and check out some examples. So, using the zero product property. When we have polynomial equations, what you are going to look for are roots, which are solutions. Okay? So if I'm looking for a solution of something for this, basically what this says is that we are going to take x minus 4 and set it equal to 0. And we're going to take x plus 2 and set it equal to 0. Wow. Come on. Okay. So now we've got some baby equations that you learned probably at the beginning of last year. And say, okay, if x minus 4 equals 0, what's x? Well, I mean, if you have to, you can think about it and say, okay, plus 4 to both sides, plus 4 to both sides. What would that be? X is equal to... This pen is really slow today. X is equal to 4. Do the same thing with this, minus 2. To both sides. So x equal to negative 2. So x is equal to 4, x is equal to negative 2. Both of those are solutions. You can substitute both of them back in there to see if it works. If I put in a 4 minus 4 is 0. That right there gives me my 0 to say, okay, I don't care what this is. I don't care what this is. If this one's equaling 0, if I multiply anything by that, I'm going to equal 0. But, so, anyway, just to work it out. 0 times 6, 0. I could also put in a 2. Actually, I could put in a 2 right here and make that negative 4. Excuse me, negative 2. But this is where the 0 comes in. Negative 2 plus 2, 0. So it doesn't matter what this first one ended up. As long as one of them are 0, that would be my answer. So, this equation down here at the bottom. X minus 5 times x minus 1 equals 0. I'm going to take both of those and set them equal to 0 and solve them separately to find the roots. X minus 5 is equal to 0. So x is equal to 5. You don't have to actually show me this step here unless you just want to. X is equal to 5. And then I've got x minus 1 is equal to 0. So x is equal to 1. So I have two answers, x equals 5 and x equals 1. Let's go on to the next page. Okay. Finding the greatest common monomial factor. So it's just finding the greatest common factor, except for now you've got letters in it too. So whenever you find greatest common factor, you're going to have to say, what do both of these have in common? What's the biggest number? What's the biggest letter? So what's the biggest number that 12 and 42 both have in common? Well, 6 can go into both. What about letter-wise? Well, this just has one x, that just has a y, so there is no letters that can come out of there. So if I take 6x, if I take 6 out of 12x, so basically like divide it, 12x divided by 6, I end up with 2x. Plus, if I take a 6 out of here, it does not mean subtract, it does mean divide. 42y divided by 6, 7y. And that is my factored answer. Next one. What can I multiply, what can I take out of both of them? I have a 4x to the 4th and a 24x cubed. Well, I can take a 4 out of both. That's my biggest number I can take out. What about letters? This has 4 x's, this has 3 x's, so I can actually take 3 x's from both. that would leave me with 4x to the 4th divided by 4x cubed, leaves me with just an x. 24x cubed divided by 4x cubed will leave me with a positive 6, and all my x's have been taken. They're all gone. So 4x cubed times x plus 6. Let's try that example here at the bottom. Factor out the greatest, let me move that up here. Factor out the greatest common monomial factor of 14m plus 35n. So the biggest number that can come out of both, 7. 7. That just has an m, that just has an n, so there's no letters that are coming out. So if I divide this by 7, I end up with 2m left over. And if I divide this by 7, I end up with 5n, and it's a positive, so there's a plus, 5n. So 7 times 2m plus 5n. That is our answer. So now, put those two things together. They are going to give you an equation such as this, and they're going to ask you to not only factor it, but solve it. So if you take 2x squared plus 8x, what can come out of both of those? A 2x, which leaves you with x plus 4. So now I have two factors, because these are being multiplied together. So I can set this equal to 0, 2x equals 0, so divide both sides by 2. And anytime you divide 0 by 2, you still get 0. So one answer is 0. And then I can take x plus 4 and set it equal to 0. So x plus 4, subtract 4 from both sides, x equals negative 4. So I have two solutions, 0 and negative 4. Example 4 looks just like it, except for I don't quite have it equaling 0 yet, so I just have to do a little manipulation and move this one over. So if I subtract 15n from both sides, I would end up with 6n squared minus 15n. And now since there's nothing left over here, there's where my 0 comes in. So 6n squared minus 15n equals 0. And if I take and factor out my greatest common factor, I've got 6n squared minus 15n. I can take a 3n out of both. So if I divide this by 3n, I would have a 2, and I would still have 1n left. If I divide this by 3n, there's my minus, and I would just have a 5 left. So I've got 3n I can set equal to 0, which is, of course, 0. And I've got 2n minus 5 equals 0. So this is just a little baby equation here. 2n, if my pen would work, it would be so nice. 2n minus 5, come on, minus 5 equals 0. So add 5 to both sides. So I'm left with 2n equals 5. Divide both sides by 2. So n is equal to 5 over 2, and it is perfectly fine to have a fraction. I wouldn't even waste my time changing that to a mixed number. I would just leave it as an improper fraction. So my answers are 0 and 5 over 2. So there are a few practice problems on the next page, so let's look at that, and then this lesson should be wrapped up. Maybe. Okay. That one's already set equal to 0 on A. So I can just factor, and I can can't take any numbers out, right, because that's just a 1 in front of there. But I can take an A out. So if I take an A out, I'm left with A plus 5. And all that's equaling 0. So I've got A equals 0, so that's one answer. And if I set A plus 5 equals 0, my other answer would be negative 5. Okay, this one, I can take a 3 and an s out. So if I take a 3s, I would be left with 3s squared divided by 3s will leave me with just an s. Minus, and 9s divided by 3s will leave me with just a 3. And both of those equal to 0. So if I set 3s equals 0, divide both sides by 3, I'm still going to get s equals 0 as one of my answers. My other answer, s minus 3 equals 0, so add 3 to both sides. My other answer would be a 3. Okay. Last one. This is the one that's not equaling 0, so you just need to manipulate it a little bit. I've got 4x squared. If I subtract 2x from both sides, so I move this one over here, I would have minus 2x. And there's my equal 0. Now that I have that, I need to factor. I can take a 2x out of both. So if I divide 4x squared by 2x, I'm left with a 2x. Minus 2x divided by 2x is 1. And now that equals 0. So 2x equals 0. 0 is an option. Well, 0 is a root. And now I've got 2x minus 1 equals 0. So if I add 1 to both sides, I would end up with 2x plus 1. And then, sorry, if I add 1 to both sides, I would end up with 2x equals 1. That should be an equal. Divide by 2. Divide by 2. My other answer is 1/2. So 0 and 1/2 would be the answer. So that's as far as we are going with that. If there are any questions, make sure to ask me in class tomorrow.